Hello and welcome to the new video. Today we are going to learn about logistic regression, and this video is going to be short as I've already written the code so that we can finish this video very soon. And logistic regression is one of the widely used algorithms. If you look around for the definition of logistic regression, you can find that it uses a logit function to predict whether it's mainly used to predict a class. Let's say to give you an example, if you take the data set like social network ads, and if you see how the ad is performing, looking at the ad, whether the user has accepted the offer or he has rejected it. So there is only two possible outcomes, that is 0 or 1. So this kind of predictions can be done by using logistic regression. Let's just dive into the code and find out. So these are the libraries which we are going to import, and I'll show you the data set. So our data set basically contains 400 rows and 5 columns, and the 5 columns are user ID, gender, age, estimated salary, and purchased or not. So 1 means he has purchased and 0 means he has not purchased. So we are going to use only these two columns of age and estimated salary and see how the logistic regression is performing. So let's split the data. So 2 and 3 and 4. So we are going to split the data into X, which has age as well as the currency or is salary, and the Y, which is the dependent variable, having 0 and 1s. So 1 meaning he has accepted the offer. Then we are going to use the test and train split to split our data into test data and train data. As you can see here, 100 and 400. So we have used a test train split of 0.25, test size of 0.25, that means the train size is of 0.75. And the next step would be, you should be very careful that you need to since age is in years and your salary will be in some, let's say, dollars, so the units are not matching and the scales are not matching, to be precise. So in that case you need to standardize, and for that we are going to use the standard scalar from pre-processing library, and all you have to do is initialize it, then fit transform it to the training set, and then apply the same standard scalar to your test set. Select and run it. So now if you go and see your data set, it's already scaled data. You can find the logistic regression class from sklearn linear model and import the logistic regression, and this random state is used just so that you can repeat the same exercise again and again. And there you go. Now your classifier has been fit to your trained data. We'll do some predictions right now. You can see here ypred is having the predictions, and if we compare it, let's say 7th one is true and 9th one is true, we'll compare it with our y-test, y-train. So we have some wrong predictions. So the thing is, we need to see the confusion matrix. In case of this kind of classification, you can always look at the confusion matrix to see how your classifier is performing. So this diagonal is what we need to target on, and this is your true negative and true positive. So you want as much less variables over here on this other diagonal. So this means that your classifier has predicted false for 3 of the true values, and 8 of the false values have been predicted as true. So there is some amount of error. Next, what I want to show you is visualize. This piece of code is the same code which we have used in previous examples, so I'm not going to explain that. And this is the training set that we are going to plot. So if you see here, it has clearly drawn a line which is separating the data into zeros and 1. You can see in the legend that 0 is represented by a red color and 1 is represented by a green color. So even though there are some values over here, it is not overfit the data. It has done a good job. We can test that by plotting the test data. So you can see that the test data, there are a few values which have crossed over this particular separation or contour. This contour plot actually gives us a good representation of how our model is performing, and in this case I'd say it's a pretty good representation. So the conclusion is that the logistic regression can be easily used using sklearn or scikit-learn logistic regression class, and it can be easily fit to our training data. And if you want to predict, or if you want to classify your data into, let's say, into whether he has purchased the particular product or he has not purchased the product, you can always go with logistic regression. So that's all for today, guys. So thank you for watching. Have a nice time. Bye bye.